Properties of dioxygen. The bond dissociation energy of dioxygen is high, and hence the reactions of dioxygen requires initiation by external heating. However, when the reaction starts, it continues on its own. This is due to the reason that chemical reactions of dioxygen are exothermic, and the heat liberated during the reaction is sufficient to carry on these reactions. Some important chemical reactions are action on litmus. It is neutral to litmus. Dioxygen is neutral to litmus. Next, it is supporter of combustion. Dioxygen is not combustible, but it is a supporter of combustion. When a glowing wooden splinter is brought in an atmosphere of dioxygen, it bursts out into a flame. Next is oxidation. It is a powerful oxidizing agent and hence can oxidize metals, nonmetals, and other compounds to their respective oxides. For example, reaction with metals. Sodium reacts with oxygen to form sodium oxide, and when it reacts with oxygen at 575 Kelvin, it forms sodium peroxide with formula Na2O2. Similarly, magnesium burns in dioxygen to form magnesium oxide. Next is reaction with nonmetals. When hydrogen reacts with oxygen in presence of electric discharge or at high temperature, it forms water. And with the dinitrogen, it forms nitric oxide. And this reaction occurs in the atmosphere when lightning occurs in the sky. Similarly, when sulfur reacts with oxygen, it forms sulfur dioxide. When carbon reacts with oxygen, it forms carbon monoxide in limited supply of oxygen. And when carbon reacts with excess supply of oxygen, it forms carbon dioxide. Next is reaction with compounds. When HCl reacts with oxygen in the presence of copper chloride as a catalyst at high temperature of 700 Kelvin, it forms water and chlorine. Similarly, when ammonia reacts with oxygen in the presence of platinum or rhodium gauge as a catalyst at 1100 Kelvin and 9 bar pressure, it forms nitric oxide plus water. And this reaction forms the basis of Oswald's process for the manufacture of nitric acid. Next is the reaction with carbon disulfide. When carbon disulfide reacts with oxygen, it forms carbon dioxide and sulfur dioxide. Similarly, when metal sulfides react with dioxygen at high temperature, they form their metal oxides and sulfur dioxide. Next is reaction with hydrocarbons. Both saturated and unsaturated hydrocarbon burns in excess of air or dioxygen to form carbon dioxide and water. For example, ethene when reacts with oxygen, it forms carbon dioxide plus water. When acetylene reacts with oxygen, it forms carbon dioxide and water. And these reactions are called combustion reactions and are highly exothermic in nature. That's why the hydrocarbons are used as fuels. Next is the action of silent electric discharge. Under the action of silent electric discharge means sparkless electric discharge. Dry oxygen gets converted into dry oxygen, that is ozone. This is the reaction for action of silent electric discharge, in which oxygen converted into ozone. Next is the respiration. When air is inhaled, dioxygen is carried by the hemoglobin of the blood to various tissues of the body, where it is used in the slow oxidation of biomolecules such as glucose, fats and oils, etc. The energy produced during this oxidation sustains life, while CO2 and water produced are exhaled. Next is the uses of dioxygen. Dioxygen is used in oxyhydrogen and oxyacetylene torches, which are used for cutting and welding of metals. Next, it is used in metallurgical processes to remove the impurities of those metals and nonmetals which form volatile oxides, for example, phosphorus, sulfur, etc. Next, it is used for artificial respiration in hospitals during surgeries by mountaineers and pilots at high altitudes. Next, liquid oxygen is used for rocket fuels. For example, combustion of hydrogen in liquid dioxygen provides the tremendous thrust in rockets. Next, it is used in manufacture of large number of compounds such as phenol, sulfur dioxide, ethylene oxide, sulfuric acid, chlorine, etc. It is also used in large scale production of titanium oxide and synthesis gas. Next is oxides. Most of the elements in periodic table, metals as well as non-metals, form binary compounds with oxygen. These binary compounds of metals and non-metals with oxygen are called oxides. And on the basis of their acid and base characteristics or properties, these are classified into following four categories: basic oxides, acidic oxides, amphoteric oxides, and neutral oxides. First is basic oxides. An oxide is said to be basic if it combines with water to form a base. For example, alkali metal, alkaline earth metals, and transition metals generally form basic compounds. Magnesium oxide when reacts with water to form magnesium hydroxide. Similarly, iron oxide when reacts with water form iron oxide or ferric oxide, hydroxide. These are basic oxides. Next is acidic oxides. An oxide which combines with water to form an acid is called an acidic oxide. The oxides of nonmetals are acidic in nature. For example, when carbon dioxide reacts with water, it forms carbonic acid. Similarly, sulfur dioxide when reacts with water, it forms sulfurous acid, that is H2SO3. When N2O5 reacts with water, it forms nitric acid. Similarly, these acids oxides react with bases to form salts and waters. Next is amphoteric oxides. Amphoteric oxides are those which react with both acids and bases. For example, aluminium oxide when reacts with HCl in presence of water, it forms hexaqualuminium 3 ion, a complex ion plus 6 Cl negative ions, in which aluminium oxide acts as a base. When aluminium oxide reacts with sodium hydroxide plus water, in this equation it acts as an acid. It forms sodium hexahydroxoaluminate 3 complex. Other examples of amphoteric oxides are beryllium oxide, zinc oxide, lead oxide, tin oxide, etc. Next is neutral oxides. Oxides which neither react with acid nor with base. For example, H2O, N2O, NOCO, etc. Mixed oxides. Metal oxides which consist of two simple metal oxides with the metal in different oxidation states are called mixed oxides. These mixed oxides show the properties of both the metal oxides simultaneously. For example, Fe2O3, FeO, when reacts with 8HCl, it forms 2FeCl3 plus FeCl2 plus 4 water molecules, in which Fe2O3, Fe is present in plus 3 oxidation state, and in FeO it present in plus 2 oxidation state, and it forms compounds with two different oxidation states. Next is trends in acid-base behavior of oxides in periodic table. When we move from left to right in a periodic table, the nature of oxide shows a gradual variation from strongly basic through amphoteric to strongly acidic. For example, sodium oxide is strongly basic and MgO. Magnesium oxide is also basic. Al2O3 is amphoteric. SiO2 is weakly acidic. P4O10 is acidic. SO2 and Cl2O7 are strongly acidic. It means when we move from left to right in a periodic table, its acidic character increases. Next is ozone. Ozone, it is present in upper atmosphere where it is formed by the action of UV radiations on dioxygen. When dioxygen comes in contact with UV light, it forms ozone. Next is the preparation of ozone. When dioxygen is exposed to silent electric discharge or sparkless electric discharge, it converts into ozone. Next is the structure of ozone, in which oxygen is sp2 hybridized and it forms two single bonds with two other oxygen atoms. And it also shows resonating structures, in which it forms double bond with one oxygen and single bond with other oxygen, and its bond angle is 117 degrees. Because of resonance, both the oxygen-oxygen bonds have partial double bond character. In other words, both the oxygen-oxygen double bonds are equal, that is 128 picometers, and lie in between those of oxygen-oxygen double bond lengths and oxygen-oxygen single bond length. Next is the physical properties of ozone. It is a pale blue gas having a strong characteristic smell. Next, in small concentration it is harmless. However, if the concentration rises above 100 ppm, means parts per million, breathing becomes uncomfortable, resulting in headache and nausea. Next, when cooled in liquid air, pure ozone condenses to a deep blue liquid and then to a violet black solid. Next, it is about 1.67 times heavier than air because its vapor density is 24 while that of air is 14.4. Next, it is highly soluble in water but readily dissolves in organic solvents such as turpentine oil, cinnamon oil, carbon tetrachloride, glacial acetic acid, etc. Ozone is diamagnetic while dioxygen is paramagnetic.